We should do illuminated television. Hotter or colder? She's out of the light now. Just remember, you don't have a PCB preview button. You only have a PCB live button. No, there's PC stage, live and preview. Top right, there's a PCB button, and that's to put your PCB live. Right, thoughts? Hot or cold? She's just stepped out. I don't actually know what that means. Oh, so. Mic working? No.
Hello, 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 hello. Hello, hello, hello.
It'll.
Hello, hello, hello.
Yeah.
Is it working now?
It'll come through on the live for a little bit.
Are we live? Cool. Hey, welcome. I'm going to take this off. I'm Melissa and I'm the regional coordinator for Evolocity Canterbury, and I'm super excited to
that, sorry?
to actually be able to be here with you all today, holding this event. So, welcome. It's me, goodness. Can we switch to the computer, please?
PC stage.
No? Okay. I'll just carry on. Excellent, thank you. So, on behalf of Evolocity, I'd like to welcome you all and thank you for coming along today. We're thrilled to be able to host you here, and we hope you find it informative and that you leave here feeling inspired and keen just to get started. Firstly, I'd like to acknowledge our sponsors, our partners and our mentors, some of whom are here today, and you'll get the opportunity to meet them as we go, but also to those who are not here. We're hoping that we want to say thank you for all your support and helping to make this year's program possible, and we couldn't do this without you. So thank you to all our partners, mentors and sponsors. Before we get started, I just wanted to let you know that we are live streaming this event and we're recording it at the same time. So the link to this recording will be sent out to you next week. So for those who have not been able to be here today, we'll be able to watch it back in your groups and in your teams and in the schools at some stage in it soon. So if there's anything you want to look back on, that's going to be a great opportunity to do so. Later in the morning, Domino's will be providing us with some yummy pizzas. So at this point, we'll also be taking some photos for Domino's social media sites and also for our own marketing purposes. So please make sure you give us a nice picture when you see me coming around with my camera. Just a few safety messages. In case of emergency, please exit through the nearest door and we will assemble out on the grass area out the front. In case of seismic activity, just remember to drop, cover and hold, and then when safe to do so, please leave the building and meet at the grassed area. Remember throughout to practice good physical distancing, mask wearing whilst inside, and outside is optional for your own level of comfort, and good hand sanitising practices. If coughing or sneezing, please perform hand hygiene afterwards, and do not attend if you feel sick or have a persistent cough. No smoking or vaping in the premises, however you're welcome to do so outside the school perimeter fence. And toilets are located just in the foyer when you came in, on my right hand side, on your left hand side of the stairwell. Finally, just remember that throughout the morning, if you need anything, please come and see me, and very shortly I'm going to introduce you to a couple of people and you'll be able to go and see them too. We want this day to be interactive, and we welcome you to ask questions as you need. So as we go through this presentation, if you have any questions, please just raise your hand, okay, and we will come to you. Thank you. Now time for a few introductions. Whilst a number of our partners couldn't be here today, we are fortunate enough to have Paul Gaynor here from the Head of Department of Electrical and Computer Engineering at the University of Canterbury, Engineering Department, and Paul will be sharing with us shortly, so maybe Paul, just give us a wee wave. That'd be great. Thank you. And Steve Thompson, who is the Year 1 Program Leader for the New Zealand Diploma of Engineering at the ARA Institute of Canterbury. You'll also be hearing from Steve a little later on as well. And there goes Steve, giving us a wave. Thank you. Some of our partners aren't featured on our opening slide. However, we have a message from Warren at RasTech Services, who writes, I have been involved with Evolocity since the beginning. Being an electrical engineer, I helped design a number of the gadgets that are used to assist with the competition program. My commitment is to introduce kids to engineering as a career, and Evolocity is a great tool to do just that. It gives you a wonderful taste as to what engineering is about and the fun that you can get from it. You probably won't get rich from it, but you will probably be richly rewarded in other ways, and all the best with your endeavours and have fun. So thank you, Warren, for your welcome message. JD from JW Diesel, Bryn from Tate, Pip and Paul from Orion, Alan from Mallow Yellow, all very much welcome you here to this year's program and look forward to meeting you at some stage throughout. Now from the Evolocity team, we've got Thomas Galbraith, who is our technical lead for the South Island, and you'll get to hear from Thomas shortly, so give everyone a wave, Thomas. Thank you. And I'm not sure if Dave is here. Dave? Oh, you are. Hi, Dave. Dave is one of our mentors, so thank you for coming along, Dave. He's going to be here as well, helping out. Before I put up the next slide and click into the program, is there any questions at this point? No? Oh good, let's carry on. Oh, that's me. That was my slide. Here we go. So we've been through the welcome. Thomas is going to give us an overview of the Evolocity, the program and the competition. Steve is going to jump in and talk to us about some designs, and Paul will then take the stage and talk to us about some EVs and more. Then we will leave here and we'll pop outside. We can look at the displays. We'll have a gymkhana run on the go. We'll have some pizza, and also we've got a couple of competition class carts that are available to be viewed, and those children who are older and will be entering competition class may have an opportunity to give that a go today. Otherwise, we've got some other carts and bikes that can be test driven as well. So, I'll hand it over to Thomas. Thank you.
Don't worry. Yeah.
Hello everyone, welcome along today. First of all, hands up who have done Evolocity before. This is not the first time. Cool. Small portion. So, for those of you who have done this before, I'll be a bit of an unfamiliar face. I've since taken on the role of the technical lead for the South Island. So what that means is basically I'm there to support all the teams in their builds and make sure that we get as many fast-looking cars to the competition at the end of the year. So I'm going to give a bit of a talk on basically what the competition is, what you have to do, and I guess an overview of the competition and how you race against each other at the end. Perhaps just a little bit about me. My background was also with electric vehicles. I spent a few years building the four-wheel drive electric vehicles at the University of Canterbury. It's a very similar program to Evolocity actually, except just a little bit bigger. We essentially design and build these single-seat electric race cars and take them over to Australia to race them. After a few years of doing that, I was a scrutineer at the competition, so similar role to what I have here, but for those vehicles. Now I'm building satellite electronics for a company called Dawn Aerospace, and also liquid rocket engine control systems. So, yeah, I guess in summary, I'm here to answer your technical questions and to make sure you get cars as good as they can be. Here's a little bit of an overview video of the competition.
So how the program works, Evolocity works, is the
Right, it seems we do not have sound.
So how the program works, Evolocity works, is the students design, build and ultimately race an electric vehicle. It's an engineering STEMs program, but built around a fun learning environment with the various universities around the country, and the fun part comes at the end of the year when they've completed their vehicle and they come to race, and that's what we've got today, the Auckland Regional Finals.
What got me interested in this event was watching other teams go through it throughout the years. It always looked really fun, then putting it all together, putting the ideas into practice, and then of course actually racing on the day.
Just generally being interested in
From the switch. Talking.
So how the program works, Evolocity works, is the students design, build and ultimately race an electric vehicle. It's an engineering STEMs program, but built around a fun learning
It's not on the
environment with
disc.
the various universities around the country, and the fun part comes at the end of the year when
On
they've
the switch
completed their
panel.
vehicle and they come to race, and that's what we've got today, the Auckland Regional Finals.
What got me interested
Anyway,
in this event was watching other teams go through it
basically,
throughout the
you can
years.
see from
It
this
always
video
looked really fun, then
few of the
putting
cars
it all
that other
together,
teams have
putting
previously
the
brought.
ideas into practice,
and
and then
this
of
is
course actually
the kind
racing
of thing
along the
that
day.
Just
you'll be
generally
looking
being
to build,
interested in motorsport.
The idea of creating an electric vehicle, hearing about Teslas and seeing them driving through Warkworth, it was really interesting to see that you can move such a vehicle with just electric power.
This vehicle is primarily constructed out of carbon fiber, recycled from core composite. Our steering wheel displays our speed and distance covered from GPS measurements using a tablet mounted on it. It's completely custom made.
We just recycled some wood that we had from other projects at school. Steering wheels from a school table, and the back end is from high school because they already had the sprockets for gears.
Inside we have an aluminium bike frame, which we have slightly bent the back forks to fit the hub motor.
Kind of experienced and learned a whole lot of new techniques, processes for like carbon fibering, electrical systems, programming, and a lot of teamwork.
Some experiences are just general, like how to build things and how to plan them.
As well as the electronic 3D printing, Damla here has been learning how to use the Arduino to program the controller and things. All those sort of skills that they would normally not get exposed to.
And hoping to find a course that I can do for 3D design and CAD design. The skills that I got from that were amazing, and it brought me into designing other things as well.
The weather has affected our vehicle's performance, obviously mainly because it's been raining, a lot of surface water today. A lot of tyres got a decent amount of tread on them. We did see the wheels were spinning at the beginning of the race, causing power loss.
Overall, our vehicle has performed better than expected, to be honest. With no excess weight on it, the motor would spin up to about 75 kilometers an hour through our readings. We did have a few stumbles here and there, but other than that, it's performed well above expectations.
Cool. You caught the important bit. So, what's Evolocity about? Well, basically, it's an engineering competition where your task as a team is to design and build a small electric vehicle that's capable of racing in the competition at the end of the year against other teams. Now, in order to make it more of an engineering challenge, we set a bit of a bounding box on what you can do to encourage a bit of innovation and encourage you to think about how you can make your vehicle faster than others. So basically, we provide the kit, and it's up to you to build an electric vehicle that considers things like efficiency and speed and driver comfort, all in order to produce a working vehicle at the end. Now, I guess it is an engineering competition, but we want to make it as fun as possible so that people are encouraged to get into engineering, because it's something that, well, it's an important path to go down, and we really want to encourage young students to really enjoy getting into engineering. These are some of the vehicles that previous teams have built. There's quite a wide range of vehicles that you can make. It could be a bicycle or a trike, or also have four wheels. And usually the powertrain kit that you get will kind of determine which kind of vehicle you want to build. Really battling with technology today. So, the competition is broken up into sort of three streams. We have the standard class, which is basically what most entry-level teams will go into. That's a motor, the batteries, and the throttle. It's 350 watts, and that allows you to basically build anything you want around that standard kit. It's supposed to be, it's not the most high-performing, but it's a really simple and easy kit to use, and it's intended that anyone who does try and use that kit will have some good success with it. The next level is the open class, where we allow up to 1,000 watts. Similar sort of rules, but just more power. The After that is quite a big step up into the competition class, where it's up to 3 kilowatt, and you kind of have a bit of a free rein on the systems you can implement. The rules are a lot more harsh because the carts go faster, so it's quite a next level engineering design challenge. It's a new class that was introduced last year, and so far it's been really successful. So part of the kit that you get from us, as I said, was the motors and batteries. And then we also provide some design guidelines to say what you should and shouldn't do in order to keep the competition fair. So this is part of our package that we provide to schools in order for you to start your build. Throughout the year, you'll probably encounter some challenges, and so we have quite a good support network around making sure schools get the technical support they need to finish their vehicles. So once you buy the kit from us, you're not left on your own. Yeah, it's just a little bit more detail on some of the kits. So even in the 350 watt class, there's 2 types. You've basically got a hub motor or a mid-drive motor there, and so it really encourages teams to sort of think broadly about what they can and can't do with an e-bike kit. Yeah. So I guess if you haven't had experience or exposure to electric bikes or electric kits before, this can be a little bit daunting, but rest assured we do provide all the documentation that you would need to get this going in a short amount of time. So we really want this to be a really unintimidating experience for especially new teams. As well as the actual kits and building the cart, we really want to encourage innovation and encourage students to be able to do things that are not necessarily part of the racing aspect. So we call that the innovation class. This is where we sort of provide some programming-based courses for students to be able to take data and parameters from their vehicle and display it to their driver that can be used for them to drive faster or more efficiently, or just in general give feedback on the vehicle. So for this, we're pushing some Arduino courses, and this is some of the kit that you'll get with that if your team is interested. So basically it's a bit of a display and a breakout board for you to interface with. So next up, it's kind of looking at the competition. So here's a couple of videos on what the competition might look like. So that was the drag race event where teams will line up side by side and you see which one is the fastest. And the winner of that competition is obviously the car that can accelerate the quickest. The next up is the Gymkhana, and this you'll actually see outside afterwards. It's more of a test of the car's agility and ability to maneuver around a course. The next up is the economy run, which tests basically how efficient you can make your car and also how efficient you can drive your car, so understanding the dynamics of an electric powertrain and how that would relate to energy usage. So for that competition in particular, it's a much bigger track than the previous ones that you saw, and basically you just keep driving until you use a certain amount of energy, and it's the team that can drive the furthest on 30 watt hours of energy. The competition class is, as I said before, it's a new one and is quite a bit more stringent in terms of design, but also allows you to go faster.
Right, that's great.
Not quite sure what happened there, but
Abu Qatar.
cool. So, you're kind of hopefully getting a bit of an idea on what this competition is about, what you need to do. The next step is, well, how do you do it? Well, for this we set out a basic skeleton of a timeline for what you should be doing at each part of the year. And in order to make sure teams are on track, we organise a bunch of build days, so a sort of communal time and place for everyone to catch up. People like myself and other technical mentors who will be there to help teams who have got particular issues, or also just teach you some new skills that you might have. So, yeah, there's a few technical specifications aspect there. That's all covered in a bit of a design manual, but probably more importantly, take away from what you need to do, well, what you can get from us this year is our build days. So for this, we, as I was saying, those communal days, we'll cover things like welding, building a cart, designing a cart, and also a bit of some information on programming and to get the data from the carts, as I mentioned before. There's a few testimonials there. If you've got the slides afterwards, they're quite interesting to read, what people have done after Evolocity. Cool, so I'll hand it over to Steve Tomset now to give a talk on design.
make it, is it just left arrow and right arrow, is it? Using the mouse to click. Thank you. Cool. Kia ora, everybody. My name's Steve Thompson, teaching mechanical engineering at ARA, basically in design, strength of materials, those sorts of topics. I want to just concentrate a little bit in this one about just getting teams started is sort of my role, is to try and encourage you to actually just make a start, try and build things and don't stress too much about the whole sort of process. So get this to go. It's all right. Okay, first of all, as you try and get started, part of it is sort of what do you want to build? Your options are, we've got some two-wheel designs in here. Some of these photos were up before. You can have three-wheel designs. They are generally quite a lot lower. They are much more stable than a two-wheel one. Still fairly limited on space. You can go to four-wheel designs. Again, much more stable, a little bit less maneuverable around the Gymkhana type courses, but you can make them really low to the ground, really sort of good efficiency, and they're much easier to lay your equipment out. You've got much more space on the frame to do that. Generally, you've got the choice of material that you make it from. So part of the design criteria is about innovation as well. A lot of people will stick to things like steel frame, mainly because steel's really easy to manufacture. You can weld it, you can drill holes in it, and the manufacturing process is quite easy. Some people use aluminium. A lot harder to join in those processes, so just be aware of those. Some innovation type people are working in timber. Don't worry too much about working in that. One of the things with timber is it has a very high strength to weight ratio. So you may need more timber in order to get your strength, but timber is way, way lighter than steel. You know, a fifth of the weight of steel. So you might use 3 times as much timber if you like, but it's weighing 5 times less. And the advantage of that is a lot of schools have already got equipment that you can work in timber. So you can glue them, you can screw it together, and timber is much more forgiving in terms of its design. So you don't have to be quite so accurate in terms of cutting things in timber, whereas you do with things like steel, you have to be much more precise about getting things the right length, otherwise they just won't fit. With timber, you just use a bigger hammer and you're good. So these were some designs that were done last time. Pretty much, it's what we've found over the years is schools tend to struggle with actually getting started. You spend a lot of time trying to work out, do we go 2 wheels, 3 wheels, what's it going to look like, how are we going to get the best performance? My general thing for schools is just build something. Get yourself a frame, stick a motor on it, take it for a spin. You don't try and build the ultimate machine the first time you do it. You will learn so much by just getting a motor, get an old pedal bike from the dump, put the motor on it and take it for a ride. The amount of stuff that you will learn from doing that will then inform what you do next. Right? So don't think you're wasting time. This is going to save you months in terms of your work. So rather than trying to come up with the ultimate design for your first one, don't. Just get in there, have some fun, take it for a spin. You'll learn way, way more doing that. One of the things just to be aware of is as you start looking at your overall concept, the things around aerodynamics. So on the screen, you can see these are a couple of drag coefficients or drag losses for vehicles, specifically bicycles. The green line at the bottom is your rolling resistance. So that's the resistance of your bearings, tyres, things that go round. The green line is the aerodynamic drag. So you can see by the time you're entering your drag race or your economy race, if you're hitting around 20, 30 kilometres an hour, your aerodynamic drag is where most of your energy is going. So to get around those, try and have shapes which have the air to be able to flow around them. So don't use square shapes. Try and use things so that the air can actually move around your object. To do that, a lot of people take low profile. So lie your rider down. Try and reduce the frontal area. So if you take a photograph from the front, how much can you actually see? So rather than trying to sit upright on like bicycles, try and lie down, or build a cart which is like a trike or a four-wheel one where you actually can lie down quite significantly. Again, don't worry too much about this for a start. Get in there, make something, and then deal with some of these issues later. For steering geometry and dealing with your wheels, have a look up online, heaps of information online. Some of the important ones are things like the Ackerman angle, demonstrated on the screen, which is your ability for your cart, so 3 wheels or 4 wheels, to be able to steer without loss going around a corner. So if you set up your geometry correctly, then your tyres won't scrub against the road and lose energy. So these are the way that we set up cars and trikes. So steering angles, and the other ones are caster and camber angles. So these are where your wheels lean in towards the, so your back wheels lean in slightly, your front wheels lean in slightly, and your caster angle, which is, you'll see on some of the carts out the front, where the front kingpins are, they are on an angle. So you'll see on the bottom diagrams, typical, a bicycle has an angle of the front fork. So all of your steering should have those sorts of things. So it makes your steering much more reliable, much more stable, especially as your speed increases. So these things are all readily available online. Just make sure at some point you go and look them up before you start trying to make your final versions. Safety. I do the scrutineering each year in terms of the final checks before you get out onto the racecourse. Keep safety in mind as you go. So for a start, as I said, just make something, get it going. Don't worry too much about the details. But when you start getting to the end of the design towards race day, make sure that you have fixed everything. Make sure your brakes are actually working okay, that they're rigidly attached to the frame, that they work properly, that your steering wheel is actually joined properly to the shaft. All these sorts of things. There's quite often in scrutineering, we're telling people, your brakes don't work properly, or this is loose, your steering wheel's wobbly, and the restrictions are we can't let you race if those things are not right. Right. So at the end, start talking to your mentors and the build day people around what you need to do for those. Your frame, make sure it doesn't have sharp edges. Make sure that it's nice and rigid, nothing's going to be falling off in those sense. The last little comment on this slide, pretty much if it comes apart, then it will on race day. So if you've bolted something on, you need to take an allowance for the fact that it will probably come apart during your race. So on the screen there is a picture of a couple of nuts that we use, Nylock nuts, which is the bottom image, and castle nuts, which are the top ones. So these are designed to stop things from vibrating loose. You will need them on things like all of your axles, all your steering, around your brake points, all the safety critical things will have to have these devices on them to stop them coming undone. Okay. Last little part for me is just a little bit on what we call transmission of forces in terms of mechanical design. This came up pretty much in last year's scrutineering when we were looking at some of the safety frames that people put behind the driver for the 3-wheel vehicles and 4-wheel vehicles. So transmission of forces, if you have the force coming up through the back wheel and then up onto the safety frame or the back of the seat, is what my little diagram is showing. If you have not got enough strength on that, then you end up with this process going on. So you can't just go, oh, I'm just going to brace the back wheel up to the safety frame or the back of the seat, and then I'm good. Because what you need to think about is where does the force then go after that? So from there you could put a brace. And that's frozen. There we go. Do that. You can put a brace down onto there. That's going to stiffen up the back of the seat. But now what you've done is transferred that force now onto the frame. So your frame is going to bend. So if you're going to do that, then you need to strengthen up that bit of the frame in order to transfer that force across. So in these, just think about when you're putting bracing around your seats, around wheels, things, don't just deal with, oh, my brace supports the load, the first load. Where does that force then go? Then goes into the next member and the next member, and follow it through as you go. And if you concentrate on that, then you're going to have a good day. So main themes for me: build something, stick a motor on it, take it for a spin, learn something from that, and then start working on your final design. So that should be all from me. Thank you.
Okay, thanks, Steve. Right, so my name's Paul Gaynor. As it says there, I'm the Head of Department for Electrical and Computer Engineering at the University of Canterbury. We look after programs like the Electrical and Electronic Engineering program, Computer Engineering and Mechatronics Engineering as well. Thomas Galbraith, who you heard from at the start, is actually one of my research students that I used to have, and he's gone on into bigger and better things from there, clearly. All right, right, a bit of a different flavour for my presentation, rather than going on about some of the, I guess, the design elements that you're going to be looking at in the competition. I thought I'd talk to you a little bit about where you might go next from high school if you have this sort of interest and you want to carry on. So I'm going to cover things from a University of Canterbury perspective, but ARA is also a great place that you can then move from high school and on into further education and developing your engineering interests. Okay, so do talk with Steve as well about some examples that he might have around the ARA perspective. Okay, so but my examples will just be from UC. Okay, so we offer at UC, and ARA would also offer as well, engineering for a vast range of hands-on and practical projects, and that'll be a major part of your studies. So it's not all, like you might have heard, it's not all maths and book work, whether you come to university or go to ARA. You can work on things like electric vehicles, and this is, obviously you've got an interest in electric vehicles being part of Evolocity, but you can also move into things like rockets and robots, biomedical devices, considering things like sustainable energy, and the list just goes on and on with engineering. It's a great enabler. All right, those are just some examples of some of the practical stuff that we do work on at UC. So you get to work with electric carts as part of your coursework. Yes, if you get into the right sort of stream early on, you can develop these single-seater independent four-wheel drive electric race cars. The rockets, some pretty specialised robotics. The one with the low-risk clinical trials was a development at UC on doubling the ability or doubling the capacity of ventilators for ICU units that were struggling with the number of COVID patients. Renewable energy, and the last one there with the people in the lab coats, we have microfabrication capability at UC that enables you to produce your own solar cells and test those out as well. Just again, because I'm from UC, I have these perspectives. We've have a relatively long history when it comes to EVs and the development of those in the research space, ranging from the 1970s, involving a small commuter car, through to race cars, even farm vehicles, and then aircraft. So that's the early days there. 1976. So yeah, we've been in the space of electric vehicles for quite some time when these newfangled solid-state electronics came out on the market. So here we have the very first sort of implementation of electronics control of an electric vehicle. Then we got really high-tech moving on into the 1980s. That's actually got some fiberglass body molding adaptation to it. Maybe a little bit ahead of its time. It uses induction motors, and don't worry if you don't know what they are, but they were what Tesla initially had been using in their vehicles to move away from the reliance on rare earth magnets being used in their motors. All right, but we kind of got there a little bit ahead of Tesla. A little bit more modern, converting a Toyota MR2 to full electric. So we did that. I've been involved with a project for a little bit of time now, converting a Toyota Land Cruiser 70 Series, a relatively local, South Canterbury high country station wanted to see if they could utilise electric vehicles in their farming capacity. So we've been doing a project with them looking at electric vehicle conversions. Not all about big power stuff. We've also been involved with projects involving sustainability and maximising efficiency of electric vehicles. So here's a student project that was involved in the Eco Marathon project. Yes, I know it's a little odd to be sponsored by Shell, but it was. And we did very, very well at that competition. Part of your coursework involving electric vehicles. So you can go from being involved with Evolocity and really be able to carry on that interest moving into tertiary studies, which is great. Oh, and of course the electric race cars. Later on in the year, when you get to do a bit of a visit out to UC, we'll bring out the electric race car, and you can have a bit of a pour over that. Can't really let you drive it. It gets up and goes a little bit too much for people who aren't trained to drive it to use it.
And we have a number of local companies that would then, after you've done your tertiary studies, UC or ARA sort of thing, that would be really, really interested in employing you. All right, so there's EVNEX. You would have seen them as being one of the sponsors. Local company, has to do with electric vehicle charging and smart management of that around the country. Kia Aerospace, an aeronautics company that are very much interested in looking at developing electric aircraft that stay airborne for very, very long periods of time, like months, providing localized communications networks that can be utilized. That's that vehicle that you can see behind them. We've got Dawn Aerospace that Thomas is an employee at, and they're doing some amazing stuff. So, and they're here locally in Christchurch. All right, and of course we've got Hayden Padden and his group there developing a pretty amazing electric rally car. Again, with one of the engineers there being an ex-master's student of mine who's their lead electrical engineer. All right, so just a little bit of a flavour of, yeah, you're getting in at the initial stages of developing electric vehicles. There's a lot more you can get into that's really amazing stuff. All right, enough from me.
Lovely. Thank you, Steve. Thank you, Paul, and thank you, Thomas. A few final things just before we go. Kits. If you have ordered a kit when you've registered, or maybe you haven't yet registered and you do want to order a kit, just letting you know that we're expecting delivery of these into Littleton Port next week. So we hope to be able to dispatch those to you shortly after that. So I'll follow up on that and I will come back to you with an email next week. I'll also email next week out a design and build activity that you can do back in your groups and schools, and I'll also send you some guides to help get you started on the process too, so it's not so overwhelming, it's just small steps, one thing at a time. I'd like to thank our sponsors and mentors for helping to make this program possible and be here today, so thank you. To Burnside High School and the Aurora Centre for their help and their contributions today to actually have this venue available for us. To Hull Moulton High School and Burnside High who have contributed the carts, and also Rod on behalf of Hornby High School has also brought the competition one here today. Thank you. Thank you to all of you attending here in person, online, and who will be watching this later on. Thank you to your teachers, your leaders for making this possible for all of you to be able to do that this year. And finally to the parents and caregivers and supporters for helping to get you to race day. Even if you don't make it to race day, even if your car or your bike isn't finished, still turn up, bring it along to race day, and there'll be plenty of people there with some good ideas to help you on those tricky parts that maybe you got stuck on, that then the following year you can finish off or re-engineer. Right now, what we're going to do is we are going to make the draw. Hopefully everyone got the opportunity to enter. We've got a wee kill switch out the front for the draw, so I'll put a number in there, pull out a number, and let's see what your raffle tickets have got. We have got green B004 Olivia. Is she here? Yeah? Yay, awesome, there you go. Well done, that's it for you. And that was donated on behalf of Electroflash, so they provide some gear too, so thank you to Les at Electroflash for that. What we'll do now is we're going to pop outside, we can have a look around the displays, we'll need a couple of volunteers to give the gymkhana a go, and then the pizza will be here shortly and we can find a nice wee spot to eat and have some pizza while we get the competition class cars set up. Alrighty, cool, thank you so much.
Do we have the second battery on standby? Do we have the second battery? This one has a projected 38 minutes.
Ready whenever you are.
So, this is the Gymkhana. They're going to do the champ ones. Focuses on auto. It's because of the sun and the concrete. It's not doing us any favours. We'll go at it after this guy's finished this thing.
Murphy's Law.
So the wee lever. Yep, where's the wee lever?
Alright, you can now take
Gain?
it up. Thank you.
No, gain.
Oh! Sorry! Sorry! Another one.
What one are you referring to?
Oh, no, there's still one more. Sorry. You ready?
I'm just trying to remember the course.
Ah, so grab the banner. That's it. Zigzag. I think there's two battens there now though. So just come back over the board. Do a full wave and I'll pass you.
Grab that.
Zigzag. Drop it off. Yeah. Come back to the wood.
Oh, yeah.
Wait. Oh, nice. Alright. Yeah.
Excellent. Well done. Thank you.
Can you take me off? That's the end of it.